So our next section is going to be about factoring trinomials. So we're really going to do three things. We're going to first go over what is a trinomial. Then we're going to talk about how do we deal with trinomials with a leading coefficient of 1. And then what happens if we have another number other than 1 out front. So a trinomial is just kind of combining two things. Tri meaning 3, and it's really nomials helping us identify it's a polynomial. So a trinomial is just a polynomial with 3 terms. And really where this comes from is from our typical foiling method. So we've dealt with multiplying an expression like x plus 2 times x minus 4. We go ahead and multiply the first terms, and that gives us x squared. The outer term would give us negative 4x. The inner term gives us positive 2x. And then the last term gives us negative 8. And so what happens when we have expressions of this form where it's x to a single power plus a constant, x to a single power plus a constant, those outer and inner are going to be able to condense, and that gives us a minus 2x, minus 8. Okay? So we know this foiling process. What we want to do is we want to start with this expression completely multiplied out, and we want to be able to write it in this factored form of x plus 2 times x minus 4. So just like the last example, we're working in this direction. Now, you're going to be able to find a ton of stuff online with different methods and algorithms and stuff you need to do. But I think the one that works most generally is just to recognize where each piece in this expression comes from. So when we dealt with this foiling process, the first terms multiplied to our squared terms. So the x times x leads us into the x squared. Okay. Then the last term, the positive 2 and the negative 4, leads us to the constant term of negative 8. This middle term really comes from just adding the outer and inner pieces together. Okay? So we want to keep this in mind when we're trying to set up what we think a possible guess is going to be. So we're going to start by factoring something of the form x squared plus bx plus c. So this is our case when we have a leading coefficient of 1. So there's going to be just a single x squared. So the way we're going to be able to guess and check, or kind of if you want to see an algorithm, you want to find pairs whose product is c, which is that last term, and then whose sum will add up to that middle term. So for this very first one, I'm going to show you this process and show you how that leads to factoring. But then I'm also going to show this in a different notation and then also go through our guess and check. So we're going to do this problem quite a few times. So using the algorithm process, we want to find pairs who multiply or product is this n number of negative 35. So thankfully I don't have a ton of options. We can do 35 times negative 1, or we can change the signs, negative 35 times positive 1. The only other way we can multiply to 35 is 5 and 7. So I have the option to make 1 positive, 1 negative. Okay. Then I'm going to figure out what the sum of these pairs is. And this is where we want it to match the middle number. So for the first one, if we do 35 plus negative 1, gives us 34. Negative 35 plus 1 is negative 34. 7 plus negative 5 is 2. And then negative 7 plus 5 is negative 2. So looking at this third pair, they multiply to negative 35 and they sum to 2. So what this tells us is our expression x squared plus 2x minus 35 will have two factors of x plus 7 and x minus 5. So you use whatever the two numbers are that multiply to the correct thing and add to the correct thing. Okay? And then we can check this out by actually foiling. We're going to take x plus 7 and times it by x minus 5. So if we do our first terms, that's going to equal x squared. The outer is minus 5x. The inner is positive 7x. And then the last is negative 35. So indeed, it lands us right back to where we started, and it is the correct factoring for this trinomial. Okay. If you like this method, absolutely allowed to use this. It gets very complicated the second we have a different number out front. So I'm going to show you another method that works when we have a 1x squared. But then I'm also going to go through our guess and check process. So first, let's do a different notation. You may have seen this at some point before, but it's called, I think, the cross method, if you want to look it up. So what we do is we put our two important numbers. We put the negative 35 and the 2. And so what you're trying to do is you want to figure out two numbers. You're going to put them in two remaining spots that need to multiply to this and need to add to this. Okay. And so you would just be kind of crossing stuff out. We already know 7 and negative 5 is the pair that does this. So it lets us factor into x plus 7 times x minus 5. Okay. But like I said, both of these methods are only going to work when it's a single x squared out front. If I were to change this problem slightly and have a 2 out front here, this method no longer works, which is why it's nice because this is convenient, but it's not going to work generally. Okay. So what I'm going to do is I'm going to go ahead and erase all of this and then talk you through this guess and check method. And so what that really means is we're identifying where each piece in that trinomial comes from. So when we go back up here, the first terms had to multiply to the x squared. The last terms had to multiply to negative 8. So what I'm going to do is I'm going to preemptively set up an expression. I want my first terms to multiply to x squared. So the only way I could do that is if it's an x and an x. And I want the last terms to multiply to this negative 35. So this is where I would go through and I would try something. Maybe we know the answer, but maybe I try a positive 35 and a negative 1. Okay. That fits the criteria for the first and last multiplying to the two things. We're going to use this middle term to check. So we haven't used the outer and inner. That would give us negative 1x. The inner would give us positive 35x. These, when you add them up, do not give us the correct middle term. So it doesn't lead us to 2x, so this is no good. So that's not the correct factoring. So we'll try again, and we'll use the terms we know make it work. So our first terms need to multiply to x squared, definitely has to be x and x. The last terms have to multiply to negative 35. So I'm going to go ahead and put my positive 7 and my negative 5. Okay. And so we've done the first terms and the last terms in the FOILing. If we do the outer term, that's negative 5x. The inner term is positive 7x. And it indeed will add up to the positive 2x. So that's how I know that this is the correct factoring. So x squared plus 2x minus 35 is going to equal x plus 7 times x minus 5. So again, you can use whatever method you really want for this factoring, but this guess and check is going to work much more appropriately. And it's not 100% a guess, it's still an educated guess because we're making the first and last terms align. Let's try a couple more of these ones with a 1 out front, and I'm going to go ahead and use that cross method. So for this one, we have a single k squared, so that's great. We want the numbers to multiply to positive 30 and add to positive 11. Okay? So positive 30, one number I could do is 3 and 10, but that doesn't add up to what we need it to. So I'll go ahead and erase and try again. Another way I can reach 30 is 15 and 2, but again, doesn't add up to 11, so that's not the correct one either. So then I'll try positive 6 and positive 5, and indeed that does add up to 11. So these are the two numbers that I need for my factoring. So this will factor into k plus 6 times k plus 5. And for one last time, we're going to check by FOILing out. So we take k plus 6 times it by k plus 5. First terms give us k squared. Outer term gives us 5k. Inner term, 6k. And then last term is 30, which indeed will simplify to the k squared plus 11k plus 30. So let's do one more before we start the more complicated with a number other than 1 out front. We have the numbers need to multiply to 2 and they need to add to positive 1. Well, 2 doesn't give us a ton of options. The only numbers or nice numbers that multiply to 2 are positive 2 and positive 1. But they add to 3. So that doesn't work. If I try it again, the only other way I can multiply to positive 2 is doing negative 2 and negative 1. But those add together to negative 3. These are the only possibilities. That's the only way I can multiply to positive 2. So neither of these works. In the case that this happens, this is not factorable. Okay, so we've exhausted all possibilities and it doesn't work. So this is called a prime polynomial. It's not going to happen too frequently, but in these nice cases with the 1 out front, we can definitely go through every possibility. Okay. Now let's consider this case when I have something other than a 1 out front. So I could have like a 5, a negative 3. You can again find a ton of processes online that give you some kind of algorithm. Your book also has a nice algorithm that you can follow, which is similar to what we did up here of finding pairs whose product is C and sums whose product is this. But it's definitely more complicated. So I really think this educated guess and check is going to be much better for you in the long run. So you want to make sure those first terms give you the squared term. The last term gives you the last terms. And then you're going to check that the outer and inner give you that middle term. And then we're just going to try whatever possibilities we can and see Did we pick something that actually works? If we didn't, then we just try again. So we're just going to do a ton of examples. Let's factor 6x squared plus 5x minus 4. So what I'm always going to do is I'm going to set up my parentheses. And I'm going to put little notes to start. The first terms should multiply to 6x squared. And then our last terms should multiply to negative 4. Okay. And so I just want to take some guesses, and then I want to see, do I get the right middle term from that guess? So let's try a first one. To get 6x squared, we could do a 6x and an x. To get negative 4, I need one to be positive, one to be negative. Let's try a negative 2 and a positive 2. Okay. They definitely multiply to 6x squared, multiply to negative 4. So now I want to see if I do my outer term, that would be positive 12x. The inner term would be negative 2x. So unfortunately, those do not add up to the correct middle term of 5x. Okay? So this is not the right guess. So let's try another one. Let's erase our work. Another way we can multiply to 6 is 3 and 2. So let's do a 3 and a 2 with an x on each of these. And then a different way I can multiply to negative 4 is a positive 4 and a negative 1. Okay. If I do this, my 1 disappeared. If I do this, that gives me negative 3x as my outer term, and my inner term would be 8x. And those add up to the correct middle term. Okay? So we could FOIL this out if you want to see the full process to make sure this is right. The first term gives us 6x squared. The outer term is negative 3x. The inner is positive 8x. And the last is negative 4. So this indeed gives us the positive 5x in the middle that we want. Okay. So this is our correct factoring. When we start with 6x squared plus 5x minus 4, it factors nicely into 3x plus 4 times 2x minus 1. Okay. So let's try a second one. Again, gonna preemptively set up my parentheses. And so I want my first terms to multiply to 2m squared. And I want my last terms to multiply to negative 6. Right? So the first one I'm going to try is putting a 2m and an m. Thankfully, that's the only way I can get to 2m squared. And negative 6, let's try negative 3 and positive 2. So if we FOIL this full thing out, first term gives us 2m squared. Outer term is negative 4m. Inner is negative 3m. Oh, outer is actually positive. Messed up my sign. And then our last term is negative 6. So if we simplify this, we are super close, but it is a positive m, and I really want negative m. So when that happens, we're really off by a minus sign. Just try switching them. So let's do 2m plus 3 and m minus 2 instead. Okay. So again, I don't need to really multiply the whole thing out because I know my first and last terms give me the first and last terms of my trinomial. So instead, I'm just checking the outer term and the inner term. And those indeed give us that negative m in the middle. So this is exactly what we want. Just to clean things up, let's get rid of all of this stuff. Our 2m squared minus m minus 6 factors nicely into 2m plus 3 times m minus 2. So I just have one more example to go through. We've got 3x squared minus 16x minus 12. And this one's a little bit harder because we do have a lot of options for this last piece. We have 12 times 1, 6 times 2, 3 times 4. And because it's negative, that means we can do positive or negative on each of these. So I'm just going to jump into a couple guesses. Okay. We need 3x squared as our first term. So let's try 3x and x. That's really the only way we can get to 3x squared. And then we need negative 12 in the last term. So let's try negative 3 and positive 4. Okay. And so if we go ahead and look at the outer term here, that would be positive 12x. And the inner term is negative 3x. And unfortunately, those give us positive 9x. So this is not the correct middle term. Okay. So that one doesn't work. So let's try again. 3x and x is still my only option for my first slots. Another way we can multiply to negative 12 is a negative 6 and a positive 2. So if we check the outer, that's positive 2x or positive 6x. And if we check the inner, it's negative 6x. Adding those together, unfortunately, gives us nothing. So this also does not work. So let's try one more because I do know the answer. So our first two pieces still have to be 3x and x. Let's try putting a positive 2 here and a negative 6 here. Okay. And the reason I'm actually knowing that this is the correct one, this middle term is pretty high and negative. So I've got that 3 out front. I want to multiply it by a pretty big negative number to get a large negative number in the middle. So when I do 3x times 6, it's negative 18x. This gives us positive 2x for the inner term. Adding those together gives me that large negative number that I want. So that is the correct middle term. So way back up here, this thing factors really nicely. 3x squared minus 16x minus 12. It will factor into 3x plus 2 times x minus 6. So knowing that I need a large negative number, that's going to be this indication that I should probably do two things that give me a large negative number together. And this is something you just kind of pick up the more you do this. Factoring is a process that the more you practice, the better you get, or the more your intuition builds for it. Okay? So again, you can use whatever type of process that you want to factor. You can use those algorithms like your book has. You can use that cross method, whatever you need. But definitely this guess and check using the first and last terms will work when we start to get to more complicated expressions as well.